Good morning students, zoology second year, digestion and absorption. The next topic, digestion in the small intestine, digestion in the small intestine. First one, the small intestine, it is various movements, various movements in the small intestine. Various movements in the small intestine. The help of the muscularis externi, they are provide the various movements of the small intestine. These movements help of mixing of food with bile juice, next pancreatic juice, bile juice, pancreatic juice and intestinal juice. The various movements of function, these helps from the food mixing with the digestive enzymes like bile juice, pancreatic juice and intestinal juice. These all the juice are mixing with the food materials. These are help from the digestion of food. These enzymes help from the digestion of food. The small intestine presenting on the various movements occurring from the small intestine. The help from the movement, these food materials are mixed with the bile juice, pancreatic juice and intestinal juice. These all the enzymes are mixed with the food. These are help from the various movements. First one, a digestion of proteins. Digestion of proteins in the small intestine. Digestion of proteins. In the small intestine, digestion of proteins. In the small intestine juice, trypsinogen, chymotrypsinogen, chymotrypsinogen. Next one, procarboxypeptidase, the trypsinogen, chymotrypsinogen and procarboxypeptidase, these all are inactive enzymes. Trypsinogen, chymotrypsinogen and procarboxypeptidase, these are all enzymes are the inactive enzymes. In the small intestine, the mucous cells, they secretion from the enzyme enterokinase. The enzyme enterokinase enzyme activate the trypsinogen. The enzyme enterokinase enzyme is inactive trypsinogen to active trypsinogen, to active trypsin. So the enzyme enterokinase inactive trypsinogen is converted to the active trypsinogen. The enterokinase enzyme releasing from the small intestinal mucosal. The small intestine mucosal membrane releasing from the enzyme enterokinase. These enterokinase enzyme inactive trypsinogen is converted to the active trypsinogen. Active trypsin. Inactive trypsinogen is converted to the active trypsin. These active trypsin also converted by the own inactive enzymes to converted to the active enzymes. The active trypsin is also activated by the pancreatic enzymes. The active trypsin also activates the pancreatic enzymes. For example, pepsinogen. So these are the inactive enzyme. So the pepsinogen presence of the enzyme enterokinase. This inactive pepsinogen is converted to the active pepsin. So these are the active. Understand? The enzyme enterokinase inactive pepsinogen is converted to the active pepsin. Next one, the active pepsin is converted to the active pepsin is the own inactive enzyme is converted to the active enzymes. Another one, pepsinogen. So the pepsinogen is a inactive enzyme. Pepsinogen is the inactive enzyme. So the presence of the pepsin. So these converted to the active pepsin. So these are the active. Understand? The pepsinogen is the inactive enzyme. Presence of the enterokinase. These converted to the active pepsin. That active pepsin is own inactive enzymes is converted to the active enzymes. Own inactive pepsinogen is converted to the active pepsin. Presence of the pepsin. Next one, chymotrypsinogen. So this is also inactive enzyme. So these are presence of the pepsin. So they are converting from the chymotrypsin. Converting from the chymotrypsin. The presence of the enzyme pepsin. So these are the inactive enzymes are converted to the active enzymes. The trypsinogen, chymotrypsinogen, procarboxypeptidase. These all the enzymes are the inactive enzymes. All the enzymes are the inactive enzymes. In the small intestine presenting on the enzyme enterokinase. These enterokinase enzymes, these are converted to the inactive pepsinogen to active pepsin. These converted to the inactive pepsinogen to active pepsin. The active pepsin is the action from the own inactive enzymes converted to the active enzymes. So these are called the autocatalysis. They are the autocatalysis. Next one, the chymotrypsinogen. They are the inactive enzyme. The presence of the pepsin is converting from the chymotrypsin. These are the active enzymes. So these are the enzymes are the inactive to convert to the active. Next one, the chyme. The small intestine, the stomach presenting on the food material is called the chyme. That chyme are presenting on the partially digested proteins. The stomach contain a partially digested proteins. The stomach chyme contain partially digested proteins. The chyme contain partially digested proteins are the presenting proteins, proteases and peptones. Proteins, proteases, peptones. Proteins, proteases and peptones. The presence of the enzymes trypsin, chymotrypsin, and carboxypeptidase and aminopeptidase. Trypsin, chymotrypsin, carboxypeptidase, aminopeptidase. These all the enzymes is converting to the tripeptides and dipeptides. Tripeptides plus dipeptides. Tripeptides and dipeptides. So the tripeptides. Tripeptides, the presence of the enzyme tripeptidase. Enzyme name tripeptidase is converting to the dipeptides plus amino acids. Dipeptide plus amino acids. Next one, dipeptides. Presence of the enzyme dipeptidase. So these are converting to the amino acids. They are converting from the amino acids. So the amino acids are the protein absorbable forms. These amino acids are the absorption of the small intestine. So they are the digestion of the proteins. Proteases, peptones. So the chyme presenting on the partially digested proteins. These are the proteases, peptones. The enzymes are the trypsin, chymotrypsin, carboxypeptidase, aminopeptidase. These all the enzymes converting to the tripeptides and dipeptides. The tripeptides is the presence of the tripeptidase enzyme. So they are converting to the dipeptides phase amino acids. Dipeptides are presence of the enzyme dipeptidase. They are converting to the amino acids. That amino acids are the absorbable forms of the proteins. So these are the protein digestion in the stomach, the small intestine. Next one, digestion of lipids. Digestion of lipids. So lipids means fats. Digestion of fats. So first one, the bile salts. These are bile salts functions. These bile salts are the emulsification of fats. Bile salts helps from the emulsification of fats. Emulsification means they convert into the small micelles. They are converted to the small micelles. Like the large fats are converted to the small fats. They are converting to the small fats. So they are the emulsification of fats. The bile salts helps from the emulsification of fats. Emulsification means these are breakdown of fats. So they are the micelles. Next one, the bile salts. So they are bile salts activate activate of the saliva, the pancreatic lipase and intestinal lipase. The bile salts are the activate of pancreatic lipase and intestinal lipase. These two is the inactive enzymes. These inactive enzymes they activate from the bile salts. The bile salts are active from the pancreatic lipase and intestinal lipase. Next one, first one, fats. The presence of the bile salts. They are the presence of the emulsified fats. That emulsified fats presence of the enzyme pancreatic lipase. Is converting to the dipeptidase and aminopeptidase. They are converted to the diglycerides, triglycerides and diglycerides. The triglycerides are converted to the They are converting to the enzyme of the lipase. Diglycerides. Next one, the diglycerides are converting to the the presence of the enzyme lipase. So they are the monoglycerides. The monoglyceride means they are the glycerol, converted to the glycerol. So fatty acids. So these are the digestion of the fats. The lipids are converted to the glycerols. So these are the glycerols. The glycerols are the absorbable forms of the fats. The triglycerides and diglycerides. The diglycerides are the glycerols of the absorbable forms of the fats. So these are the digestion of lipids.